Hello, mathematicians, puzzlers, and other curious people. Somewhere in the course of your process as a mathematician or toward being a mathematician, you will end up needing to do more than one calculation as part of the same process. So you'll need to decide which of those calculations to do first. And one way we deal with communicating about that in mathematics on Earth is the order of operations. This is a decision that mathematicians here on Earth have agreed to. It is possible that mathematicians on other planets handle it a different way. This isn't an inevitable consequence of any just basic axiom of how numbers work. Now, that said, even though it's an agreement, it's not a completely arbitrary agreement. There's some logic to it. So a lot of people remember the order of operations using the acronym PEMDAS, but it's important to break that down a bit. Parentheses come first. Parentheses and other grouping symbols. Well, that just means that the grouping symbols do what they're supposed to do. They say this is the bit that is done first. And of course, if you have nesting grouping symbols, then you could have the first, and then inside that, the first of the first. But then let's get to the actual operations instead of just saying, okay, grouping symbols do what they're for. We've got exponents, multiplication and division, and then addition and subtraction. So exponents come before multiplication. Well, exponents are like repeated multiplication. Multiplication comes before addition. Well, multiplication is like repeated addition. So one pattern we can notice in the order of operations is that repeating operations come before what they repeat. Now, what about the division and subtraction? Why are they where they are? Well, one thing to remember about division is it's the same as multiplying by a fraction. So for example, dividing by 7, like if you want to do 3 divided by 7, is the exact same thing as if you do times 1/7, like 3 times 1/7. So the way we say this is we talk about the inverse operations because you can multiply by an inverse element. So your inverse operations are kept together. So like I said, even though it's an agreement that has some logic to how it's put together. So here's how we use that in practice. I've got one expression here, 2 plus 7 squared divided by 2 plus 1. Now, one thing that's important here is that 2 plus 1 is in a denominator. Even though it's not written in, we treat it as if that whole denominator has grouping symbols around it, so we do that calculation before we divide. So sometimes there are grouping symbols other than parentheses, and the fraction bar kind of acts like grouping symbols around both the numerator and the denominator. When you're putting something into a calculator, by the way, you will never mess yourself up by putting parentheses around the numerator and around the denominator. Sometimes it won't be necessary, but it'll never hurt. So what operations do we need to do first because of grouping symbols? Well, that 2 plus 7. Well, I know that's 9, and I'm going to go ahead and drop the parentheses now because I see that now I've got that down to a single number. That's a good time to drop parentheses. Also, that 2 plus 1 is equal to 3, so we've got 9 squared divided by 3. So now what do I do first? Exponents or division? Well, I do exponents first because division is with multiplication. Exponents, 9 squared is 81, 9 times 9. So what I've got here is 81 divided by 3. I happen to have that one fresh in my mind. If you don't, grab a calculator. 81 divided by 3 is in fact 27. So 27 is the simplified, evaluated way to write this expression here. Here's another one. Pi times 2 plus 4 squared divided by 2. This time we don't have any grouping symbols. Now this pi is a little tricky to work with, and depending on what you're doing, sometimes you'll just leave that as pi. This time I'm going to approximate pi. So pi is about 3.1415 9. I'm going to round this to 2 decimal places at the end, but I'm going to bring along 5 decimal places in my steps. That'll just help make sure that if I have any rounding errors along the way, they'll be over here in like the 5 and the 9 in places that would get cut off at the end anyway. So we'll have 3.14159 times 2 plus 4 squared divided by 2. And again, that's approximately equal to what we start with. Okay, so then what happens? No grouping symbols, exponents. Oh, 4 squared, well that's 16. It's a good idea as you're working these to write what you simplify underneath what it's simplified from, because that just helps keep it organized. And then you can just copy in the rest of the problem around it. Now I'm using the equal sign because this expression here is exactly equal to the previous step. So now I'm on multiplication and division. I see I've got that 3.14159 times 2, so that will be 6.28. I want to say 2, but the 5 is going to have a 1 to carry, so 3, 9, 18, plus, let's see, 16 divided by 2 is 8. Then I've got, let's see, 6 and 8 is 14.28318. But then I was going to round that off to 2 decimal places, so that will be about 14.28. There's my final answer. So it's not so hard, just keep track of what you're doing and keep it organized so you can see where different things came from. And other than that, calc you later.